Good morning. Today we are going to discuss on the next part of the topic, that is solution. From the chapter solution we will be discussing the next part of the topic. Today we will be mainly discussing on the topic that is on the colligative properties and on the colligative properties. But before that, once again I want to repeat that what is Raoult's law, as many of you have still a doubt on Raoult's law. So what was Raoult's law? Raoult's law always had discussed on binary solution. So what is binary solution? We had seen two examples of binary solution. One was between two volatile liquids and one was between a volatile liquid and a non-volatile solid solute. So today we will be discussing, suppose, let us, what Raoult said, that the partial vapor pressure is directly proportional to the mole fraction of the solute. Or the partial vapor pressure, if we remove this constant of proportionality, what it will be? P01 x1. What is P01? It is the vapor pressure of pure liquid. Means when the liquid itself is only boiling, no other solute is being added to it, its vapor pressure is always more than the partial vapor pressure of the solvent in the solution. Now on that day I had given an example on the basis of this axis, where mole fraction should be over here. Let the mole fraction, as we all know, that x1 plus x2 becomes 1. So if x1 becomes 1, then x2 will be 0 at this point. Similarly over here, if x1 becomes 0, then x2 will be 1. Now since x1 is 1, therefore the vapor pressure or the pure vapor pressure over here of the solute or the solvent, whatever you take, will be marked over here as the maximum one, since mole fraction is maximum over here. So for x2, the pure vapor pressure of x2 will be maximum over here. Now if we join these two, what we will be getting? This is the total pressure of the solution, that is P1 plus P2. Now if we join this and if we join this, then this one will be P1 and this one will be P2. Now see over here, as the pressure is decreasing, mole fraction is also decreasing along with it, and when it becomes, the mole fraction becomes 0, pressure becomes constant over here. Similarly for P2 also the same thing. So for P1 if this one, then for the solute will be P2 is equals to P2 naught x2. So this was what we have discussed about Raoult's law on that day. So keep this thing in mind, that this was the thing. Now we will be discussing today on colligative properties. What is colligative properties? Let us discuss. Colligative properties as it says, when a solute is dissolved in a solvent, the vapor pressure of the solution decreases. This we all have seen, that as I said, that P1 is equals to, or rather P01 x1. So always the vapor pressure of the pure solute or the solvent will be greater than that of the vapor pressure of the pure solvent. And what is colligative properties? Colligative properties does not depend on the nature of solute. Means if I have taken 10 gram of urea and I have made a solution, and if I have taken 10 gram of glucose and I have made a solution, both the solutions will be having the same vapor pressure. There will be no difference because it does not depend on the nature, but it depends on the number of particles or atoms or molecules of the solute. So this is what colligative properties. There are 4 colligative properties. Number 1 is relative lowering of vapor pressure. Now let us take an example before this. Let us take an example. This is a solution, or this is a solute, solvent. Now, as we all know, and I have closed this vessel for some time. Now, as it is being boiled, what will happen? This volatile liquid, this is a volatile liquid. What will happen? This will vaporize. These are the vapors. Now there will be a particular point, and we all know that the vapors are coming from the surface of the liquid, and similarly some of the vapors are also returning back to the surface of the liquid. So there will be a particular point where the volatile liquid will vaporize. Now when I am adding solute, a non-volatile solute, to this solution, what will happen? The vapor pressure over here will start decreasing because the solute has occupied the intermolecular space between the solvent molecules, and therefore vapor pressure over here will decrease. Now as it is being stated, as we have seen in Rowlett's law, P1 is P01 x1. So as I said that the vapor pressure will decrease, so what I can write? I can write from here that P1 naught, that is the pure vapor pressure, minus the partial vapor pressure, equals to P1 naught, and x1 I can write it as, means P01 minus P1 equals to P01. I can write in place of P1 what? P1 naught into x1. From here I can write down P01 P1 equals to, if I take this P01 common, so it will be 1 minus x1. Now P01 minus P1 equals to P01 x2. We all know this is known as lowering of vapor pressure, but this is not the colligative property. My colligative property is relative lowering of vapor pressure. So how can I write it down? It will be P01 minus P1 by P01 equals to P01 x2 by P01. This one and this one cancels. So what remains? P01 minus P1 by P01 equals to x2. This is what we call as relative lowering of vapor pressure. Now from here we can further on study that P01 minus P1 by P01 equals to x2. Now suppose I have taken N2 becomes moles of non-volatile solute and N1 becomes moles of solvent. Then according to relative lowering of vapor pressure, what I can write? N2 by N1 plus N2. Now we always know that the solvent, number of moles of solvent will be greater than that of the solute. So we don't take into account the number of moles of the solute in the total solution, because suppose if N1 is 1000 and if N2 was 2 and if I had increased it another 2, so it would not be any factor to us, because 1000 was there and along with that I have had increased 2 moles of solute more, so there would not be such a significant change. So what we will be writing? N1 by N2. So this is what we call as relative lowering of vapor pressure. On the basis of this is what we are calling as relative lowering of vapor pressure, and on the basis of number of moles of solute and solvent, this is another how to calculate the relative lowering of vapor pressure on the basis of moles of solute and solvent. Now this was one of the colligative properties. The next one is elevation of boiling point. Elevation of boiling point. What is elevation of boiling point? Elevation of boiling point, before that we need to know what is boiling point. We have studied since childhood that when a liquid vaporizes at a particular temperature, we call it to be as the, or when a liquid starts to changes into vapor at that particular temperature, we call it to be the boiling point. But we can also say the temperature at which vapor pressure of a liquid is equals to the atmospheric pressure. That is what we call as boiling. Means suppose this is a solvent, and now when I am supplying heat to it, what it happens? It starts changing into vapor. Now at the same time there is a